morning, angels. We have a catastrophe on our hands. I have a student who can't seem to comprehend factoring. She lives here. Go find her and teach her about factoring.
We're on it.
We're on it.
We're on it.
I'm out of time and all I got is 4 minutes. 4 minutes, yeah. I'm out of time and all I got is 4 minutes. 4 minutes, yeah. I'm out of time and all I got is 4 minutes. 4 minutes, yeah. I'm out of time and all I got is 4 minutes. Come on. Yeah. Break that. Save the world.
When you hear the, it's time to practice some problems in the pamphlet.
We are OConnells Angels, and we're here to help you with your factoring crisis. I think this is our girl.
I don't get factoring at all.
It's hard at first, but after some practice,
We're confident that you'll get it.
So, what's the first thing that comes to your mind when you think
Of factoring. No. GCF.
This is an acronym for Gregory, Carl.
Fitzgerald. Or greatest common factor.
This is the most important thing you'll ever need to know while factoring.
I'm already confused. What's a factor?
Well, the two numbers multiplied together to get the product are the factor.
Okay, now I get it.
What is the GCF of 48a cubed and 36a to the fifth? First, list all of the factor pairs. Now, circle the common factors. We have 12 and a cubed, therefore the answer is 12a cubed.
Now let's move on to the next method, binomials.
Use the binomial method when x equals 1 or negative 1. If c is positive, then the terms have the same sign. If c is negative, then one term is positive and one term is negative. If b is positive, then the factor with the larger absolute value is positive. If b is negative, then the factor with the larger absolute value is negative.
For this one, all you need to remember is backwards.
FOIL. FOIL stands for first, outside, inside, last. Let's look at this problem. Start by multiplying the first terms. Then, move on to the outside. Next, multiply the inside terms. And finally, multiply the last. Once you've done all that, combine like terms. Factoring a binomial is just the opposite. In this problem, -5 is the sum and +6 is the product. Now what two numbers multiply to 6 and add to -5? -2 and -3. Therefore the answer is x minus 2, x minus 3.
Do you feel comfortable with this method now?
Yeah.
Try factoring 2x squared plus 14x plus 24.
Who are you gonna call?
Buster!
Always do GCF before any other method. Let's look at this problem again. First, you have to take out the GCF, which is 2. Then, you can continue on factoring.
The next method is called difference of perfect squares.
So, let's list the first 10 perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Only variables raised to an even exponent are perfect squares. Let's look at the formula for difference of perfect squares. Now let's use it for this problem. A is going to equal 2x and b will equal 3. Then you just have to plug it into the formula. Try factoring this problem. First, take out the GCF, which is 4. Then, you can go on to using the difference of perfect squares method to finish.
Let's kick it up a notch.
Oh boy, let's see it.
Okay, let's try to factor 49m to the 8th plus 25.
Who are you gonna call?
Buster!
This method only works with subtraction.
This method, sum and difference of perfect cubes, like the last one, only applies to certain numbers. Now, can you name the first 6 perfect cubes?
Obviously. 1, 8, 27, 64, 125, 216.
Now let's look at the formula for sum and difference of perfect cubes. Make sure to take notice of where the signs are. Now let's try it with this problem. A is going to equal x, and b is going to equal 2n. Then just plug it in.
Now let's talk about the exponents that apply to this rule.
Wait, I think I know. Any exponent that's divisible by 3 is a perfect cube, right?
Now you're catching on.
We are group girls, yeah, we'll factor it out. Factor, 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 we are group girls, yeah, simplify it out. We are group girls will always help you, yeah, yeah. And all you have to do is group, angels will be there.
Grouping's easy. It's just like taking the GCF of 2 separate terms and then the GCF of that. Sounds confusing, but it really isn't.
Use grouping when there's no GCF for all of the terms. Group the terms with the common factors, and then take the GCF from each group. Look at this example.
Good story from A to C.
You want to factor me, you better listen carefully.
Slide bump to the back and that's AC. Then you must be...
And then it's all easy peasy. The AC method is helpful when A is a composite number. The AC method uses grouping, but there are only 3 terms, therefore you must make a 4th term. Step 1. Multiply A and C. Step 2. Find which factor pair adds up to B. Step 3. Use grouping. Let's try this problem. 6x squared minus 19x plus 10. The AC is 60. Out of all of the factors of 60, the pair that adds up to B, negative 19, is negative 4 and negative 15. After grouping, you get 3x plus 2 times 2x minus 5.
I get it!